Symbols and sets of numbers. Anytime you see braces, these represent sets of numbers. The natural numbers, also known as the counting numbers, begin with 1. You count by ones like you did when you first taught how to count. 1, 2, 3, 4, 5, so on, so on, so on. They never stop. Whole numbers are the same as natural numbers, except they begin with the number 0. Now some symbols that you may see: equals, of course. Not equals to is the equal sign with the line through it. Less than, notice which way it points. Less than points to the left. Greater than points to the right. Some people, one way to think of it is great right shark. Greater than is to the right. Anytime you see a less than with the line underneath it, that means less than or equal to. Key word is or. This one is greater than or equal to. So let's look at these few examples and see which of the following are true or false. By the way, what less than actually means is if A is less than B, that means A is to the left of B on the number line. Greater than, if A is greater than B, that means that A is to the right of B on a number line. So if you want to use a number line, you can. You don't have to, though. Question: is this true or false? Is 8 less than 6? The answer is false, because everybody knows, or should know, that 8 is greater than 6. That's a false statement. Is 100 greater than 10? The answer is true. And once again, if you use number line, well, 8 is 8 to the left of 6? No. Is 100 to the right of 10? Yes. Is 21 less than or equal to 21? Since it is equal to 21, the answer is true. It can only satisfy one of those. And if it does satisfy one of those statements, less than or equal to, then it's true. Is 21 greater than or equal to 21? The answer is yes. It's true. Is 0 less than or equal to 5? No. Well, yes. 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 0 is less than 5. That's true. Is 25 greater than or equal to 22? Yes. The answer is true. Now let's do some translations right quickly involving these inequality symbols. These are all inequality except for the equals. 14 is greater than or equal to 14. Actually, the key word is. But this phrase all goes together. So we have 14 and then we have another 14. The question is, what goes in between those? Well, is greater than or equal to. How would you express that? Greater than points to the right, or equal to is the line underneath it. 0 is less than 5. So we have a 0 and we have a 5. Is less than. Less than points to the left. That's all you're doing. Now let's look at some more sets of numbers. Integers. Integers are the same as the whole numbers. Remember, the whole numbers start with 0 and you count 1, 2, 3, 4, 5. Integers include those, except they also include the negative integers, or negative natural numbers, I should say. Negative 1, negative 2, negative 3, negative 4, so on, so on, so on, so on. Rational numbers. Rational numbers are pretty much any number that can be written as a fraction. It's kind of a way to think of it. And it's any number that can be written in the form a over b, where a and b are integers and b isn't equal to 0. Can't be equal to 0 because you can't divide by 0. Which means that a and b cannot be decimals. So let's look at some examples of rational numbers. 3/4. That's a fraction. It can be written as 3 over 4. Or it's also known as 0.75. See, another definition of rational numbers is the numbers whose decimals either end or repeat. 3/4 is a fraction whose decimal ends. 0.25, its decimal ends. It's also the same as 1/4. 7 is same as 7.0. It's also the same as 7/10. Look at this number, 0.3 to bar over it. 0.3 to bar over it is the same as 1/3 because its decimal repeats. So any number that you pretty much see that doesn't have a funny symbol can be written, or is a rational number, because it can be written in fraction form. Now, numbers that cannot be written in fraction form are irrational numbers. They're not rational, of course. What that means is their decimal never ends and it never repeats. It takes a funny symbol or a strange pattern to write them down, but there is no pattern. Keep that in mind. So in this class, what you really want to think about is are numbers with funny symbols, like pi. The decimal for pi, 3.1415925, ... it never ends and never repeats. Square roots, square root of 2, it never ends or never repeats. You can do cube roots, cube root of 7, it never ends or repeats. ... Now don't be misled into thinking that square root of 4 is an irrational number. The square root of 4 is the same as 2, therefore it's rational. So keep that in mind. Real numbers, pretty much any number you see in this class, or any number that exists, or any number that can be written on a number line. So in this class, any number that exists, that can be either rational or irrational. Anything that's listed on this paper is an example of a real number. So those are just some definitions.